Welcome to the 2021-2022 edition of Bachelor at IAIK. So today I'm happy to present how this project Bachelor at IAIK works and how you will get to your thesis together with my colleagues. And I will welcome first Stefan Mangert. Hello, Stefan.
Good morning. Hi.
So the IAIK, already an old institute, right? So how many years do we have it already?
Wow, that's a good question. So, more than 30 years actually.
Yeah.
I don't know how long we actually have the Bachelor at the IAIK event meanwhile.
Mm-hmm.
But it has meanwhile, I think, already a tradition for more than 10 years. So we're doing this event actually to bring together, let's say, the researchers we have at the institute and the students, and I hope many of you are present today in order to help us actually establish these connections, because these are very, very fruitful connections that often lead also to papers in terms of research that later on gets published. Because for all activities we do together with students related to projects, be it internships, so I just get a sign. So is the volume okay?
Yeah. Oh, is it not? So maybe I have to turn up the volume on my side a bit, but I'll try that then. Okay.
So we're just cross-checking. Is the volume now okay? Looking towards the others. So I just continue speaking.
Yeah.
We also need to do research on audio, it seems. So maybe we do a bachelor thesis on that as well. But meanwhile, after that many years of COVID, there are ways to get out of it. Okay, so what else do I want to say? Yeah, so basically it's about bringing together students and researchers, because all the projects that we do at the Institute, like master's projects, bachelor's projects, master's thesis, bachelor thesis, and so on, we always try to link this towards current research activities we have at the Institute. And this often then also leads to joint publications between people that do their project at our Institute and the researchers at the Institute. And this is why actually the first point that I would like to go to are the so-called Student Research Excellence Awards.
Mm-hmm.
So these are awards that we're handing out each year to people where exactly this worked out. So when a person did either an internship, some project at the Institute, and the joint work with the people at the Institute then led to some publication at an international conference. And actually, I will start right away. So I just need to click myself to the right location actually here as well.
Yes. I also have the slides here. Then I can also show the names and what they worked on.
Just one.
So this is actually a pretty nice opportunity for students. So they work on research topics directly with the researchers, and then co-author the publication, and with that have some international visibility already during their bachelor's or master's.
Exactly. So you're in the control of the
slides.
Of the slides. Yeah. Then let's go to the first one.
Okay. So the first person I have here is Stefan Weigelhofer. So Stefan Weigelhofer, yes, I see the hand waving in the stream. Hello, Stefan.
Hello. Hi.
So how are you?
I'm very fine, thanks.
So congratulations to your awards. So you worked on this paper, SegWalk, Protecting Page Table Walks Against Fault Attacks. And that was published at the HOST conference in 2021. Exactly. Congratulations.
The presentation was in December, and yeah, it was great fun to work on that project together with Robert Schilling.
Very cool.
And for being so successful with your work, so what you will get is, so we have this nice actually award that you can actually put into your office or at home at some place. So this is the Research Excellence Award of the Institute. So congratulations for that.
But there's also something else, right?
Yeah, there is something else. I just need to find it. So this is a small present that we have. So it's very small, but it has a valuable content. So this is a 200 euro. This is 200 euro to get nice food in one of the Iola restaurants here in the city. So you can select where you want to go and whom you want to take with you. So 200 euro should be sufficient for 2 people to have decent food. So you can also maybe share it up to 4 people, depending on how much you want to eat and drink. And so have a nice evening, enjoy, and celebrate your success.
Thank you very much. That's a really great honor. Thank you.
Congratulations. So, and let's directly continue with the next awardee. That's Christopher Schinner. Do we have Christopher also in the stream? I don't think so. But congratulations, of course, to Christopher. So the paper with the title SSI Strong Authentication Using a Mobile Phone-Based Identity Wallet Reaching a High Level of Assurance. And it was published at Secrypt in 2021.
Exactly. So here we have the award that Christopher then will receive. So this is on self-sovereign identities and was published at this applied conference, Secrypt.
Mm-hmm. Mm-hmm.
Again, so just to make sure, so I don't do it for all the 10 awards that we give out, but everybody gets these vouchers, so everybody can go for dinner and have a nice evening with friends.
Mm-hmm. Okay, so let's continue. So this was a master thesis. The next one is Alexander Palmisano, and he worked at our institute in a summer internship. So I think we have Alexander even here. Hello, Alex.
Yeah, hi.
Hi. Congratulations to your award.
Thank you.
So this paper was Online Shielding for Stochastic Systems. And
yes.
It was published at NFM 2021. So, congratulations.
Yeah, I previously we talked with Bettina. So this is a NASA Formal Methods Conference, right? So the name doesn't suggest this.
Okay, interesting.
And so you're actually we're doing so maybe on the content, right? So you're trying to shield AI's learning algorithms, right?
Exactly. So you can't really make sure that it's completely safe. An AI, if you just trained it, and we build shields around that actually checks the state of the AI and the action, and then says this is not allowed or this is allowed.
Okay, cool. So actually you have been working with another person, Julian. He's actually the next awardee.
Oh, yes, but I also don't have Julian in the stream. So let's congratulate Alex one more time, and then let's move on to the next awardee. So
yeah, the awardee, this was exactly the point. So this is Julian, but I think Julian is not here, so the applause goes to both of them. So this was this paper on the sheet.
Yeah, we worked on the same thing.
So then we continued Julian, and then we have the next awardee. So thank you, Alex. So let's continue with the next one. So this is Lukas Posch, and he also worked on formal methods, and this was at the ATVA conference in formal methods. So this is Tempest, synthesis tool for reactive systems and shields in probabilistic environments.
Yeah, there are again 2 people on that paper. So the first one is Lukas.
Mm-hmm.
The conference is held virtual this year, but actually it would have been in Sydney, right? So bad luck to COVID.
Yeah, that would also be a far distance, right? So
exactly.
Then we have a bachelor thesis here, and also another student that worked on this. That is Stefan Pranger. Let's see whether we have Stefan in the stream. I'm not entirely sure whether he was able to join. If so, yes, I can see him. Hello, Stefan. I can't hear you, but we want to congratulate you to the award for this master thesis, and we can't hear you, but that's no problem. So Stefan, thank you for joining us, and of course you will also get the award and the voucher. So have a nice evening, a nice dinner then. And
yeah, and actually one important point is that Stefan is also on the next slide, right? So we had to make a special award for him because we actually have 2 papers on there. So he has a double award.
That's also very nice. So congratulations and thanks for joining us. So we continue with the next awardee, and that's Martin Grassberger, and he worked also in the formal methods group on adaptive shielding under uncertainty.
I think he's not here, right?
He's not here, unfortunately.
I also briefly talked with Bettina before. So ACC is one of the top conferences. It's an A-star conference, and so congratulations for placing your paper at this top conference. Actually,
that's very good.
And so it has something to do with so they simulated actually how to shield learning algorithms in the context of traffic lights in Helsinki. So I think that's a pretty cool application. And there are again 2 people working on this. So the first one was Martin. This was his first award, and the second one.
Oh, we will have that one maybe later. It's at least not the next one on my list.
That's later.
Yeah. Okay. So let's first continue with the next one. That was a master thesis by Thomas Schuster, and he worked on speculative dereferencing of registers, reviving foreshadow. And that was actually a paper. It was published at Financial Crypto in 2021. And that was actually a paper from my research group. And it was pretty nice because we showed there that you can revive foreshadow under certain conditions. This foreshadow attack, pretty powerful. And Thomas did a lot of the implementation work there and figuring out how these things work.
Yeah, I'm just showing the award again. So Thomas can also show up and or come to the institute and receive his award and the vouchers for the for the dinner.
And then we have the next awardee, that's Richard Sadek, and he worked that was in research in your group, right?
Exactly, that was Richard in my group, but this was supervised by actually a master thesis that was supervised by Samuel Weiser. So essentially it's about an isolated environment where you essentially, this is one of the core problems we work here in the systems domain. You always have multiple pieces of software, and you want to be sure that if one becomes bad by either being attacked or being maliciously programmed, you don't have a chance to attack some other parts of software. And this was actually published at Usenix 21, which is a top tier conference in security, also an A-star conference, the highest ranking. So congratulations to Richard again.
Congratulations. So let's right away continue. We have a lot of awards, but this is actually the last one that I have on my list here.
Okay, our lists are synchronous. It's also my last one.
Oh, okay. Great. So this is Peter Grassberger, and he also wrote a master thesis, and this was in the applications area, right?
Exactly. So this is was published at IFIPSec. So this is also a nice conference. Venue, I don't know where it was. This year I guess it was also virtual as usual. So we're currently missing the nice conference locations, but also a very nice conference. And so congratulations also to Peter.
Congratulations. And with that, we are done with the awards. So you can see that there are a lot of awards. We have a lot of students that work on current research topics and contribute so much that they get awards, and they really contribute to this research field, advance the research field by contributing to these publications and publishing these research findings. So with that, we will go over to the next step. Now that you've seen what is possible, like the awards that you can get, the research that you can create, the insights that you can create as part of your bachelor or master project. We, of course, want to go to the next step and check how do we get there? So how do you get there and get into the same situation of contributing to research and potentially winning an award? So we go over to the administrative info, and there I also invite Maria Eichelseder into the stream. Hello, Maria.
Hi there. Nice to see you all. Or well, not actually see you, but at least see a number that represents all of you.
Yeah, actually, I can also make space for Maria, right? So I will be back for later on for the systems area, I think, but then I leave the floor to you two for presenting the administrative topics.
Sounds good. So then see you later.
See you.
Okay, so with the administrative info, we actually have 3 courses that represent this project Bachelor at IAIK. First, it's the introduction.
And here we're starting really in little steps towards this final goal of having some interesting research or paper. And the first one that Daniel was just about to mention is the course that probably most of you here are registered for, and that's Introduction to Scientific Working.
Of course, but that's just the introduction, and there we learn a bit how to write, how to structure maybe some research project. But then the bachelor thesis is where the actual research is done, and maybe on top of that, the bachelor project.
Yeah, so the idea here, why this YouTube stream is called Bachelor at IAIK, but we sent the invitation to the Introduction to Scientific Working people, that's because we hope that most of you, or many of you who are working on the introductory writing course, where we'll teach you some of the basics, will be so interested in the topics that they continue to do a bachelor thesis. So you don't have to do that. If you're not sure at the moment, there's no need to already sign up for a bachelor thesis, but it's highly recommended to do both in the same area. So if you believe you would like to do a bachelor thesis with us, which I can highly recommend, then it's best to already start working with your topic for the Introduction to Scientific Working course. If you're not so sure yet, we also have a number of pure ISW topics that are more small and don't involve your own research work so much. And this bachelor topic, this can give you some additional ECTS. So this is in the same area as your bachelor thesis, but if it turns out that your bachelor thesis is so interesting that there's a lot more work to do, then you can sort of attach that on top of the bachelor thesis. So Daniel, can you maybe go to the next slide so that we can see what this means in terms of work?
Yes, so we have, of course, ECTS numbers that we give for each of these courses. So there are 2 ECTS for ISW, for the Introduction to Scientific Writing. Then we have in ICE 8 ECTS for the thesis. In computer science and in software development or software engineering and management, it's a bit different, right? So in the old curriculum, we had 14 ECTS, which is now split up into a mandatory thesis part, which has 7 ECTS. But on top of that, there's also an elective course, a bachelor project that you can take on top of that if you want to do more practical research, more practical work here.
Yeah, so you see the picture is rather complicated. This should also answer one of the questions that I saw in the chat, namely, why doesn't the computer science bachelor contain ISW? Well, it did not in the old curriculum because you had a different course with a similar goal there, but it does in the new curriculum. So I guess most of you who are registered for ISW are in this new curriculum anyways, because it has been in place for, I think, 2 years or so now.
Yeah.
So that's probably the column that's relevant for most of you.
Yeah, exactly. So that's basically the part about the ECTS.
Let's have a look at what we offer here in this program.
So what do we provide? We give you the opportunity to work with us on current exciting research topics. So you will experience the real world research. You will be a researcher for the time that you work on this project with us, this whole Bachelor at IAIK project. You are part of
course, we're going to help you with this. You'll be part of our team and we'll provide some input. So in particular, we are offering several short courses, which we call labs, which take a few hours usually, where we introduce you to some of the basic skills and techniques that you need to work.
Yes.
So we'll start with a few writing labs, Daniel.
I would even say tricks, right? Yeah, for the writing lab, that's something that we that actually Casey Posch introduced several years ago, and then together with Michael Schwarz, I took that over at some point, and we changed the format a bit. And what we try to give you there is tricks how to be efficient at writing up your thesis, at structuring what you need to do to get to a written thesis. And I would really call it
not just any thesis, but a really good result.
Yes.
So something that you can be proud of.
and I would really say tricks, because of course you can just go and say, well, I know how I write a text and I will just write something down. But the tricks that we tell you will mean that you save a lot of time. And that's why it's valuable to go to these writing labs. And the quality, the outcome will be better by using these tricks. Then we also have a presentation lab. We have to see how we do that. I think last semester, did we have the presentation lab in the end?
No, we weren't able to do it, unfortunately, because we usually do this in a lecture hall. So this is, if you're doing ISW, you're only going to get some direct input from your supervisor. But if you decide to continue with your bachelor thesis, we have this presentation lab planned for next April. If Corona permits, let's see about that, where you can really practice how to speak in front of a large audience. So, for example, in lecture hall I-13.
Exactly. So let's maybe go through the deliverables, right? Because there are some deliverables, of course, if we have ECTS, we want to see something for the ECTS. And in Introduction to Scientific Writing, it gives you 2 ECTS. And on the other side, you have to write a short report, some background on the scientific question maybe, and also give a short presentation. So this is like 4 to 5 pages maybe that you have to write.
Yeah, and it's going to be mainly literature research work. So you get some basic reading material, maybe a few papers, and you're going to go through this and write a short summary. But you're also going to frame this in the context of some scientific questions. So of course, you don't have much project work yet to do for this, so no experiments or so. But you should still have some question that you're answering that you can't directly read off the paper and that you're framing as your contribution in this report. This will be topped off by a short presentation in January. By short, I mean really short, so less than 10 minutes. Where you can practice your speaking skills. In particular, this is going to be in English. So you're going to practice your English speaking skills, which are really useful to have.
Yeah. Then, of course, the bachelor thesis and the bachelor project. So let me maybe describe the bachelor project first, because that's a nice thing that you can use to glue together the Introduction to Scientific Working and the bachelor thesis on the other side. So the bachelor thesis will be a thesis with a lot of pages that you write up, something like 2 times the number of ECTS. The bachelor project in the middle would be an opportunity to do research and focus on actually implementing something, experimenting something, and documenting what you are doing. So the bachelor project is one opportunity there to do more research. The bachelor thesis
and to
then
do more implementation work.
Yes.
So in particular in the thesis, if you do the bachelor thesis with us, you're definitely going to work on some project. So you're definitely going to do something practical, which you describe in your final thesis. But the project is really about taking this to another level, really going into more depth and also providing some useful documentation for your product to make it more useful.
Because you can imagine for 7 ECTS, and then you have to write, let's say maybe 14 pages. You can imagine that in 7 ECTS, then it's difficult to fit in the same amount of research as you could fit in 14 ECTS if you also take the bachelor project. So that's why we sell this as one package where we say, okay, that's Bachelor at IAIK. That's how we envision this. You take the Introduction to Scientific Working course, then work with us on a concrete research question, code a lot, do a lot of experiments in this bachelor project, and then write up these interesting results in a bachelor thesis, and hopefully also add these results into a paper that is then published.
And if this whole process still sounds a bit unclear, maybe let's go to the next slide where we see the timeline for all of this.
Yeah.
So we are now in the very first line. So it's mid-October, and today we're going to present to you the topics that you can choose for ISW as well as for your bachelor's thesis. For ISW, you need to select your topic in the next 2 weeks. So the deadline is on November 1st. That's Monday in 2.5 weeks. By then you should write to me and confirm to me which topic and which supervisor you've picked. We'll go to the details of this later. Also in November, we are going to have the writing labs that we already talked about. So these are going to be several instances. We're first going to talk about structuring a scientific paper, then about some style questions, the question of how to sell your contribution, how to convince the review of it, and also make them understand what you did. And finally, we'd also have a unit on LaTeX style and how to properly typeset your results.
Yes, also very helpful if you don't have much experience with LaTeX yet. That's definitely very much recommended. It's much more work if you have to learn that on your own. So the next
and in
part,
particular, it's also going to look nicer if you do it properly. If you write it the way that people who are used to reading scientific papers expect it.
So the next part,
after the labs or throughout the labs in November and December, that's what Daniel was getting to, you're going to prepare or work on this document. So you are going to have occasional meetings with your supervisor and prepare this report, do some background reading, and also prepare your presentation.
Which is then to be submitted in January. So the report and also the presentation, and this is in January. So this basically is the end of the introduction to scientific working, and then it continues with the project and the thesis. And you can already, so if you have an interesting project and during introduction to scientific working, you realize that you can already start with doing the research. You can already start working on a bachelor project. So this can then go already through January, maybe even start before January if you want to, then go through January, maybe to February, March, and then we continue with writing up that thesis in the end, and the thesis presentations would be planned for June. And to get there, of course, we have also 2 intense working blocks, one in February probably and one in early April, so that it's not in the time where lectures take place, but where you can focus on the work for your thesis.
So we'll see how we're going to organize this. Usually we had these intense working weeks really with us at the Institute. So this was, of course, a great opportunity because you would be right in the middle of the people who you're working with, and they can provide you input much more easily. You're going to sit next to other bachelor students and going to be able to help each other. Let's see if Corona permits us to do it that way. That would be great. Otherwise, you'll, of course, also be supervised and encouraged to work in particular in these intensive working times, but it's not going to be as synchronized. There is some questions in the question session, so let me maybe come to those. The last one is whether it's possible to start in the summer term. So you can generally start the bachelor thesis anytime that you like. And in particular, most of the work for it is, the default time for doing it is in the summer term. If you're also doing the ISW, this is unfortunately timed to a strict schedule, namely the one that you see here. So if you want to do ISW, you need to start now and sign up for a topic until November 1st and also do your presentation in winter term.
Exactly.
Bachelor thesis is more flexible. So it's recommended to do it in the summer term and maybe start during the term break already. But if you have some time conflicts or so, it's no problem to shift this to a later time. So it's best to just talk to your supervisor about the timing, whether there's any timing critical thing. For example, if you're helping them with a publication, then there might be some deadlines involved. But generally, it's quite flexible. Let me maybe also come to the second question that was posted just before, and that's regarding to the number of pages you have to write. So the question is, if you are doing the old CS bachelor thesis, do you really have to write 28 pages, even though half of it is practical? Well, yes, because the practical half is already factored in. So it's already the idea that writing is only part of the CTS that you do. So there's already a factor in there. And
writing will also not consume half of the ECTS there, right? So the writing is a smaller part. You will do way more research will invest way more time into research than into the writing.
Exactly. But the write-up should still be proportional to the amount of work that you do, and that's defined by the ECTS. So the factor that we're giving here, this factor of 2, holds for all of the variants that you can do.
Okay, so then the next steps is, today we present the topics, and right after this stream, we will all go on Discord, and there you can directly talk with potential supervisors and chat with them, ask them what they want to work on, and maybe you have ideas what you want to work on. You also will find the projects on the website, so you can also ask them questions about these projects that are described on the website. And the goal would be that the next step should be to select a topic pretty soon. And as soon as you have done that, then agree with the supervisor on that, and then send us a confirmation email by November 1st. And you do that you send the mail to Maria, CC your supervisor.
And I confirm it back to you so that by November 1st, we should have a full list of participants. That actually fits with the question that I just saw in the chat, namely somebody's asking whether they can participate in the ISW class, even if the group is already full. Well, in particular, if you're planning to do a bachelor thesis, this is actually highly recommended. So it's best if you send me an email describing your interest, and then I can still register you. If you were... If you don't want to do the bachelor thesis as well, I'm not sure if it makes sense, but just drop me an email. I can still register people if there is a good reason to do so.
Okay, great. So anything else? Otherwise, I would say let's go through the research areas.
That sounds great.
Okay, so let's...
Here again, I'll be back in a moment.
Yes, see you later. So, and I'm welcoming back the people from the first area that we're talking about is the system security area. And there I will again add Stefan, welcome Stefan back into the stream. And I also welcome Lukas Schinner from my research group.
Hi.
So he's also here. And then I will also, that's basically it. So you two will then present the system security area.
Yeah. So maybe just also a short note to what was said before. So it was a lot of information that many got on the stream. So maybe just to give you orientation, there is a lot of flexibility of how to combine things. So if you're confused, then just get back to us. So you can do small bachelor thesis, big bachelor thesis with project, just ISW, ISW plus whatever. So there are all kinds of variants. So just to finalize this on that. But as Daniel pointed out, in most cases, and what we think makes the most sense, if you really start with ISW and then do a bachelor thesis or combine it with a project to have something really large and do everything in one area, because you double benefit, right? So you read the literature first in ISW, then you do some work, and you write the stuff up, and you get 3 courses basically all for one topic. And in particular, in the systems area, this is makes a lot of sense, because you read once, implement something, and get all the credits for it. Because we have topics that take a certain time until you get into them, and so this makes a lot of sense.
Exactly. So system security, what can students expect in this research area? I have a word cloud here. Maybe I will show that. It says things like software security, but also hardware design. How does that fit together? Maybe Stefan.
Yeah, so maybe let's get started in that direction. So what we have and what our institute is actually also good at in terms of research is really that we cover all the different technology layers, right? So security is a topic that it relates to the hardware, where you can root some security properties, but it goes all the way up, of course, through the operating system layer, through the applications, and on each layer problems can arise, and you need to research security mechanisms. And it's a big question of how you combine all this. And we see many problems in practice actually arising due to the fact that people just think about security just at one layer and forget about the other layers, and then big problems arise in practice, right? So this is a particular a topic that created a lot of attention in the media through the work that was done in Daniel's group, and the topics that also Lucas is working on, right?
Exactly. Maybe also an interesting question for the students is, what can they expect? So maybe something that the students already know is the lectures and courses that they already had. And I see one word here is operating systems. And in general, there's the word system several times in this word cloud. So Lucas, which lectures would you say, if students like them, which are a sign that they might want to start a thesis in this area? Operating systems, maybe?
Operating systems is definitely one of them, yeah. So you get, in operating systems, you get fairly low level, which is something that we usually do. So we mostly get even lower level, right?
So that's the microarchitecture keyword.
Microarchitecture. So sorry, go ahead.
So please.
Okay. So where we mostly work is, I'd say, the fuzzy border, or the cracks between ideal hardware and software, which is microarchitecture.
So if someone says, okay, operating systems was not low level enough for me, if you want to go further down the stack, then that's
so sometimes you also have topics that are just on the operating system level.
Maybe also sandboxing. It says sandboxing here. I think Claudio is working a lot on that, right?
I think he is, but I'm not sure if we currently have topics there.
Oh, okay. So sandboxing, we have caches.
But if you are interested in something particular there, you can just ask.
Yes, definitely.
So in summary, maybe if you like the courses Computer Organization and Networks in the first place, or that it is in the third semester in parallel to system level programming, that is the course by Daniel, operating systems, and you also like the systems topic that are in Introduction to Information Security, that is your area actually, where you want to do a bachelor thesis or doing ISW. So also, it's about implementations, it's about designing attacks, it's about designing countermeasures and working on problems in real world settings. That's essentially what we do.
So that's also a good sign if someone likes these courses. Also, operating systems would also be an indication that they would also enjoy working in your research group, right? Because you also work on these low-level software.
This was actually the point I wanted to make.
Yeah,
exactly.
Yeah.
So this is exactly the point for the entire area. So I just rush a bit because I think we're running out of time. So maybe just also to throw in a bit of a name for the third person that was on there. So there is also Sushoy. So that's essentially combines. So if you'd like to do crypto and implementations, then this is the stuff that Sushoy does. So in our area, just to the summary, it's about implementations. It's about attacks on crypto processes, operating systems, and that's it.
Great. Then I would like to thank you two again. So thank you, Lucas. Thank you, Stefan. And I will move over to the next area, which is formal methods. So, and let's see, we also should have people for that. I already see Bettina. Hello, Bettina. And I also see Vedat. Hi, Vedat.
Hey.
So, let's see, does it work? I'm having a bit of an echo here from one of you two. Maybe from Bettina, but I'm not sure. But maybe it's gone now. Let's see. So formal methods. So this is Team Blom, it says here. What are you working on in formal methods? I again have a word cloud here. It says a lot about logic, formal methods, correctness.
So what we try to do is we want to develop methods and tools so that you can prove that your stuff is correct. So no matter if you're developing hardware, software, or AI, we want to show that this stuff is actually doing what it's supposed to do. Okay, I think I really have an echo on it. Could it be?
Yes.
Okay, then I give over to Vedat. Vedat can do that.
Okay. Vedat, we can't hear you, unfortunately. So let's see. Maybe you have the wrong microphone selected. That could be an issue. So we will see in a second. And Bettina, checking whether the headphones solve the problem is a good idea. But I still see an echo on the audio.
Speak again. Does it work?
This one should work, right?
Yes, we can.
Okay, Maria says it works.
Okay, now we can hear everyone and the echo is gone. So sorry for the short delay here. Now everything is fine. So logic, correctness. So what topics can we expect as students here?
Should I?
Go ahead, yeah.
So as a student, you can expect topics that somehow combine two research areas together, because formal methods can be applied to many things. In particular, what Bettina is doing a lot is applying formal methods to AI and computational intelligence. So to some system that is not designed by humans directly, but instead learned or generated in some other way, and you want to make sure that it fulfills some correctness and security properties.
And then you can prove that it is secure, basically.
Yes. So depending on what you're looking at, you can prove, for example, that an AI is not going to do something stupid by building like a small container for it that disallows the AI to kill you, essentially. And it also relates to security. So in security, you often want to prove
that the AI can't kill me, maybe.
Yeah, but in security topics, so for hardware designs or for software, you want to prove that actually the guarantees that the algorithm is giving you regarding security is also fulfilled in the implementation.
So for instance, let's say I have a mechanism to isolate programs.
Yes.
Then you would basically prove, like formally prove, that they can't interfere with each other.
Yeah, so this is a very often used property, this non-interference, where you prove that stuff cannot mingle with each other and you essentially have isolation in some sense.
So that's super interesting. Maybe let's try whether Bettina, the audio works on your side now. Maybe a question about lectures. Which lectures would students, if they enjoyed the lecture, which lecture would it be that indicates that they should work in this area?
So in the Bachelor, this is logic. That's why the password is so big on your slide. So if you like logic and compatibility and playing with S&D solvers and SAT solvers, then it's imperfect for you. I give to Vedat, so I have such a huge echo on it. It's not fun to talk.
Okay.
Yeah, so the big lecture is obviously logic and computability. That's held by Bettina. And many students we had previously for Bachelor at the IAIK came because they were interested in this course, and they can expect to apply the stuff that they learned there to some interesting new application areas such as AI or security. Another course that is also interesting would be dependent on the stuff that you combine with formal methods. For example, computational intelligence would be the one for AI, or would be information security.
Okay, so those math courses, be good in some math lectures to start something here.
So in general, no. So you don't need anything like analysis or, I don't know, discrete math, maybe. I mean, it's useful, obviously, but it's not a hard requirement.
Of course. So I will be able to start a thesis topic, start some research in your area also, if I'm let's say average in those courses.
Yeah, obviously.
Okay.
So
that's good to hear. That's good to hear for me.
That you're really interested in logic, and in systems, and then you can, if you visited this course, then you have an idea of what is coming at you in the bachelor thesis.
Okay, thank you. Thank you, Bettina, and thank you, Vedat. I will move over to the next area at this point. Bye. Thanks for being here.
Bye.
Okay, and then I need to invite the next two speakers, and that's Maria again for the Crypto and Privacy group, and also Daniel Carles. Hello. So, crypto and privacy. I mean, we all want to have privacy, right? That's sounds like an important topic.
And we need some basic mathematical building blocks in order to be able to achieve that. And that's exactly what our area is working on. So the foundational techniques to make sure that we can do anything secure at all, which means we work, for example, on encryption algorithms, on designing them, on breaking them, on implementing them, on applying them. And applying them is something that happens in particular in your group, Daniel, right?
Oh, yes, of course. But we don't necessarily, in my group, I mean, we use the algorithm.
No, I mean the other Daniel.
Oh, I see. No, we are...
problem with too many Daniels here?
Yes. No, in my group, we are just using the algorithm, put input in there and get output out there. So we don't understand how they work.
Yeah, so I always like the example by Maria. If you look up to the left of your browser, there's this log symbol probably there. And all of the stuff that we do kind of fits in there in some fashion. So we build new algorithms that might be used in the future. We try to break old ones. And especially in the coming years, we try to build algorithms that are secure against attacks that will be coming up with powerful enough new hardware and physical phenomena like quantum computers.
So quantum computers will break everything? Is that right?
Everything that's used at the moment. So most of it, let's say.
Well, not everything, not symmetric crypto.
Most of it, yeah. Yeah, so,
okay.
But symmetric crypto is never used in, at least in the TLS, in the internet setting, it's never used solely. So it's always combined with some aspect of public key crypto, and pretty much all of those are broken in the future. So we try to prepare right now. And also me and Maria are both involved in official standardization efforts to get this stuff ready for everyone.
So cryptography, and also you mentioned math in the beginning. Do I need to be an expert in math to start working on one of these topics?
No, you don't need to be an expert mathematician, but you shouldn't be afraid of math, exactly. So if you open a document and there's maybe a sum symbol or so in there, if you run away squeaking, then maybe crypto is not the area for you. But we have we work on several different layers. In particular, some of our topics are actually implementation topics, where you take the algorithms and implement them, or maybe try to attack the implementation, for example, with the use of fault attacks.
But why would you try to break a crypto algorithm? I mean, we want them to be secure. We don't want them to break, right?
Of course.
That's correct. But in order to know whether they're secure, we need to try and break them, right, Daniel?
Ah, I see. Yeah. Okay, that makes sense. Yeah.
Yeah, so we want to be ahead of some potential attacker in figuring out if something is indeed insecure, and then we can work on fixing it before this gets publicized. And I guess you, Daniel, have a lot of experience with these kind of things.
Yeah. But of course on a different layer, yes.
Yeah.
But it's the same argument that we need to find attacks before someone else finds them, because that someone else could be malicious, right? We are not.
And we are the good guys.
Exactly. So what else do we have on there? Multi-party computation. We have there homomorphic encryption, lightweight. So these would then be concrete topics that students would work on, right? So this is really, let's say, cutting edge research, new techniques that we
and a lot
need
of these
but
things
don't have yet.
Yeah, people haven't actually probably heard, at least in the bachelor, because the main course that would be interesting for people that are interested in this area is, of course, information security. And they're the first part where you have seen probably me and Maria in some capacity there.
So you would say
if you're really interested in this crypto part, then these are the essential building blocks that we will be working with in many of these topics. But there are also a lot of new fancy crypto things that you haven't heard in this course. And if you are interested in very modern things, then this could also be an avenue to explore for you.
So that sounds great. So I guess you will be flooded by students right afterwards in Discord, because so many people liked InfoSec, the course. And as they just said, if you liked InfoSec, the class, then that's the area to work in for you. Thank you for being here. And I think I will directly go over to the next area, and that is secure applications. So goodbye. Thanks for being here.
Bye.
Okay, and the next area that I have is secure applications. And I think I also have someone in the stream here, if I'm not mistaken. Let's check. Do we see them? Yes. Hi, so this is Jakob and Bianca. And you're in the secure applications area. So maybe let's also go to the word cloud here, so that I can ask you about topics there. So secure applications, it's already in the name that we're talking about more applied things, more real world things. Are we talking about code that will run on customers' machines?
Yeah, I mean, we're definitely talking about taking the theoretical concepts and the academic concepts that the other groups work on and translating those into actual consumer software. So actual software that people in the real world will use. So we work on allowing interfaces that allow developers to use cryptography. The group develops its own Java API for cryptography. We also work on the Austrian e-government scheme, so the mobile phone signature, which students are probably familiar with.
Yeah.
Our group has worked on that.
And now called also the electronic identity, so which will be the EID.
Yeah, the new EID that is being rolled out right now. We also have a part of that.
And people will probably write some code there. And maybe this is also a good orientation for people, whether they would like working in that area. So people like different programming languages. Are they constrained by the programming languages? Are there any typical programming languages that you often use in these projects?
Not necessarily. You are fairly free. I mean, you are expected to have a fairly wide range of languages you're familiar with. So you shouldn't be like, if you are completely afraid to ever write C code again after taking operating systems, then this is probably not the group for you. You should be have some degree of familiarity with every language, or be able to familiarize yourself with every language.
Yeah, okay. So I need to be able to read some code and maybe introduce some small bug fix or something like that.
You should be able to understand the language. Yeah.
That sounds very interesting. So this is a lot about bringing things into practice, making like the real world secure. Which classes would you say in the bachelor's, but maybe also in the master's, would be related to these topics?
So for the e-government angle, we do offer in the master's a dedicated e-government course, which I believe is offered in the summer semester. I'm not sure if it's offered in the winter as well.
Yeah.
And
in the bachelor's, maybe also InfoSec? Is it?
InfoSec definitely. I mean, InfoSec is probably going to be relevant for any of the crypto teams, right? But yeah, if you enjoy the parts of InfoSec where we talk about actual real life vulnerabilities, then yeah, that's definitely a contributing factor in choosing our team.
That's great.
Also the introduction to coding, because if you did not like the coding part, you.
Yeah, okay, but that's probably for everything, right? Yeah. But yeah, so if you enjoy thinking about how would I actually use this in practice, or how would somebody actually use this in practice, then yeah, that's a decent contributing factor.
Sounds great. Anything else that we should add for the students to give them as orientation? Otherwise, you will also be on Discord right afterwards.
Yeah, we will be on Discord.
Okay, that's great. Because then, I mean, let's show them the Discord link here. It's also down on the left in the YouTube description, so you can just click it if you're not on a Discord server yet. And there we will have rooms where you can meet potential supervisors and ask them about the questions. You might have to subscribe the ISW channel, but I will check that in a second as soon as I'm also on Discord. So thank you too for being here, and see you in a second on Discord. Bye. So, and with that, I will ask Maria to come on stage one more time, and then we can close the session. So you heard about the 4 areas that we have: system security, crypto and privacy. We had formal methods, and we had secure applications. And that's basically also now the 4 areas that you can look up in the Discord, and where you can talk with potential supervisors and try to select a topic. Because that's only 2 weeks until November 1st, and you want to get that done, I guess.
Yeah, so on Discord, if you join and sign up for the Discord icon, so that's the pencil symbol, it will show you the ISW category, and there you can find 4 main lobby channels. So we have a lobby for each area, where you will find the people who just presented the area. So for example, Jakob and Bianca for the secure applications area, or myself and Daniel for the cryptology area. So there we will give you some more general information about the topics in our area, give you an overview. The cat just threw over the, some furniture, okay. And we also have some individual channels where you can go in case you want to have a more detailed discussion with one of the supervisors. So the supervisors of many of the topics that you find on the website will be available there for individual questions, and you can go to your own separate room if you want to discuss in more detail, or also if you want to find out whether it's better to you for now to just start with ISW, or if you're also already having an eye on a particular bachelor thesis topic, whether you want to already reserve that for yourself.
Yes.
So I hope to see many of you there, and looking forward to many interesting thesis topics.
Okay, well then, see you there in a minute. Bye.
See you.